EET 105 inductors problem 1116. In this problem we're going to investigate the reversing the initial current. So we have a 36 volt source with a switch, inductor 120 millihenries, and resistor 3.9 kilo ohms. Notice that the initial current is 8 milliamps going this way. We're going to define IL going this way, and VL polarized in this fashion. Write a mathematical expression for the current IL and VL following the closing of the switch. Take careful note of the polarity. So II is minus 8 milliamps because IL is going this way, and it was given that 8 milliamps is going the other way. IF is 9.23 milliamps, and the way that you get that is in the final circuit, this is a short circuit, so it's like it's not there. So you just have the resistor and the voltage source. So the current is 36 divided by 3.9K, which is equal to 9.23 milliamps. Tau is L over R, 120 millihenries over 3.9K, 30.77 microseconds. And then the formula for IL is this formula. When you plug and chug, you solve it and you get this. Notice that there's still a negative sign in here. When you do KVL around this loop, you have plus E minus VL minus VR equals 0 at T equals 0 minus. But VR, that's right before the switch is closed. But V sub R equals IR times R equals negative IL times R, which is equal to a minus 8 milliamps times 3.9K, which is negative 31.2 volts. So V sub L, solving this equation here, equals E minus VR equals 36 minus a minus 31.2 equals 67.2 volts. So VL equals the 67.2 volts times E to the minus T divided by 30.77 microseconds. So then it says sketch the waveforms IL and VL. IL starts off as negative 8 as defined by the problem, and it climbs up, induces this current till it gets to the final value of 9.23 over 5 tau. VL starts off at plus 67.2 volts, and then it declines and decays down over 5 tau to 0. And then if you did the problem 15, the final levels are the same. Transition period defined by 5 tau is also the same.